x is equal to 0 and x is equal to a give you capital X equals 0 and x is equal to 0, sorry, y is equal to 0 and y is equal to b gives you capital Y is equal to 0. So either capital X or capital Y goes to 0, the entire wave function goes to 0. Yep. Now what is the wave like actually? Okay, first let's write the solutions because we know that. The solutions would be square root 2 by L sine of, okay, so psi, let me introduce these two quantum numbers nx and ny is equal to root 2 by L, root 2 by A in this case, sine of nx by x by A, another root 2 by B, sine of ny by y by B. Yes? That's the solution to the two equations, and then I multiply that. The energies for the first one, so which is Ex plus Ey, so happens to be n squared h squared by 8m a squared plus n squared h squared by 8m b squared. ठीक है? What are these waves like? The waves are on this rectangle. So the first wave, when n is equal to 1, nx equals 1 and ny equals 1, is, if you look along the x direction, this wave is like this, right? If you think of the first term, that's the wave along the x direction. Along the y direction, the wave is also like that. Yes? So, in general, the wave is like this rectangular sheet going up with this mountain coming over here and then going down with the mountain going down to the valley. Right? What happens if one of them is 1? So, nx is 1, but ny happens to be 2. So then ny would behave more like this, right? So if you still see along the x direction, the wave would be going all in up. But if you see along the y direction, then half of it would be down, half of it would be up, right? So that's my x direction, where everything is up, okay? And that's my y direction, where half of the wave is up, half of the wave is down. Okay, now it gets more and more difficult to keep on imagining these things. I would suggest you could look into acting so that it gives you these patterns of the waves. I mean, 2-2 would be one quarter down, one quarter up, the other quarter down, this quarter up, like that. So, going in sync like this. Don't ask me to imagine that, okay? There's an interesting thing that happens if A equals B. I don't need to worry about the waves. I mean, the waves would be like 4 by A squared sine of nx by x by A sine of ny by y by B. B is equal to A, sorry. But I cannot write sine square because nx and ny are different. Energy comes out to be nx square plus ny square times h square by 8m a square. Right? Now what happens? The lowest energy is in units of h square by 8 ma square. The lowest energy is 2, not 0, not 1, not even 1, because neither of the ends can be 0. If the energy doesn't matter, but the wave function, if you look on the top, if either of the ends is 0, the wave function goes to 0, which is not acceptable. So the first one is 2. The next one is, so let me write down nx, ny, 1, 1. The next one would be 1, 2, which is 5. Or it could also be 2, 1, which is also 5. So I'll have 2 of these levels. Next one would be 2, 2, which is only one possibility. Again we have 3, 1 or 1, 3, which is 10, right? We have again 2 possibilities. Now, what it says is, two things. We never saw this kind of thing in a one-dimensional box. This is known as degeneracy. We say that this particular state is degenerate. First thing, we did not see this in a one-dimensional case. It does not ever occur in a one-dimensional system. You see this in a two-dimensional case, but you would not have seen this in the rectangular case. You could actually thought out the energy levels. Maybe by chance we might get it. But that's not called degeneracy, that's accidental. The true meaning of degeneracy is not only that the energy levels are equal, but also that the wave functions are converted from one to the other by some symmetry operation. If you look at the wave function 2, 1, as I described to you, this fellow going up and down like this, maybe some cuffs like this here, something like this. If I rotate it 90 degrees, it becomes 1, 2. The 2, 1 becomes 1, 2. Exactly, the wave function would overlap. In the case of accidental, it could be like, a combination of nx square, ny square, a square, b square could give you the same numbers, the same value. But by rotation or by any symmetry operation, you'll never be able to get one wave function into the other. So, symmetry is the cause of degeneracy. Only when we made it to the symmetrical square would you get something else. In fact, you could go on and see the three-dimensional case. I don't know what kind of waves would those be. Maybe the entire sphere or the entire cube just going out in all 6 directions. Yeah, and coming in. Yeah, maybe like that bagpiper. No, it goes like that. No? The entire 3D thing goes up. Okay. The last thing for today's lecture would be the postulates, which